Hello, everyone, and welcome. Today, we're going to be starting off, as always, grounding ourselves in the importance of the skills that we're doing. So, our objective today, before we leave this session, is to be able to clearly define what an expression is and write an expression based off of real world problems. So, starting off, sometimes, I don't know if you've ever seen this, like Guinness Book of World Records, look at it in the news, random stories will pop up with like huge eating competitions, something like that. So this popped up. I think this is like an ice cream shop in Tokyo, and they can do 8+ scoops on a cone. So logistics of that seem crazy. One, to just get it there in the first place, but two, like wouldn't that definitely melt before you eat it? But neither here nor there. Um, as a math teacher, I see something like this, and I think about how much does that cost, and how do they determine the cost of this ice cream? So, say for example, you just want one scoop. What's the difference between one scoop and 8 scoops? So we can actually use our skill today to take a look at something like this and see, okay, how much would this ice cream cone actually cost? So a pricing model for that ice cream shop, we can take a look at here. We see that if one scoop costs $2 and 2 scoops cost $4, we can write an expression that would allow us to solve for however many scoops there might be. So maybe you're feeling particularly hungry that day, you want 10 scoops, or challenge that record. They have an eight scoop cone. Let's make it even bigger than that. So of course, all of these things cost money. And in order to do that, you have to be able to calculate it. So even say, for example, you're working at McDonald's or Burger King, and instead of a McDouble, someone wants 4 patties on the burger. If you're checking them out, you need to basically be able to use your math, use some kind of expression to be able to calculate the cost of that burger. So that's the real life application of what we're doing today, is to be able to look at things like this, create an expression, and then determine a value for whatever it might be that we're looking at. So to see relationships in the real world. So our definition for today, we are looking at expressions. So write expression as the word. And our definition of expression is a combination of numbers, symbols, and operators that produce a value. So an example of that might be, in that ice cream example, $2 per scoop, so 2 times X, and then maybe if they charge you $1 for a waffle cone. So this would be like the scoop and then the cone. So this is an expression right here. So it's a combination. We have some numbers, we have some symbols, we have some operators. So again, multiplication, addition. So those are all examples of things that we're looking at here. What an expression is not is an equation. So expressions and equations are different. The easiest way to tell the difference between them is an equation has an equal sign. So if you're looking at an equation like y equals mx plus b, that's an equation. It has an equal sign. That is not an expression. All right, so just our quick guided steps here on the bottom. So first you want to determine your variable or your unknown. So in the ice cream example, we don't know our number of scoops that we're going to determine, right? So it gave us some examples like 1, 2, and 3 scoops, but we don't know how many. So that's going to determine our price. Next, we want to determine the operation. So the key for this is we were doing $2 per scoop, so we were multiplying 2 times X. Sometimes it's going to be addition, subtraction, or division. So there's many different operations, even, radicals, exponents, things like that can come in there as well. So just be careful. It's not always going to be 2 times something. It's not always going to be multiplication. So just think about what you're doing. Think about the application of the context. And that's a good place to ground yourself for number 2. And then finally, your last step is to actually write out the expression based off of the information that you have there. So in theory, an expression in and of itself, the definition, we're mostly just focusing here on the idea of it's not an equal sign, just determining a value. It's more or less like I like to think about it in more intuitive terms, like it's one side of an equation. The hard part is going to be reading and interpreting real world examples and writing expressions based off of that. So that's going to be kind of the interpretive challenge piece for today. So if we want to look at some examples, So we have a phone plan here, and maybe this is paying, how the pay-as-you-go phones, I think they're called like prepaid phones. So Jalen's phone plan has the following cost. If she uses 1 gig of data, it's going to cost her $15. If she uses 2 gigabytes of data, it'll cost her $30. If she uses 4 gigs, it'll cost her $60. So maybe this is the example that the Walmart prepaid phone gives you. And based off of this, you have to determine how much is it going to cost. So what we don't know, and it's hard to determine beforehand, is how much data are you going to use? So this is what we're trying to focus on. And based off of the data, what is our cost? So data determines cost. We don't know the data. Once we know that value for the data, though, we can determine the cost. So the variable, our unknown, is we don't know the data because we don't know how much we use. And we do know the cost, right? It's telling us the cost per gig of data. So we're seeing, okay, 1 gig is 15, 2 gigs is $30. So it costs $15 per gig. We know that. We know the cost. We just don't know yet how much we are using. The next question, again, important to think about, what operation are we using? So let's try this out. So if we have data and we want to do plus 15, if we plug in 1, we would get 1 plus 15 is $16. And we can check our table. No, that doesn't work. 1 gig does not cost $15. What about 2 gigs? Maybe it'll work for that. 2 plus 15 gives us $17. Okay, so it doesn't look like the operation we want to use is addition. So let's try another method. Maybe it's multiplication. So it'd be 15 times the amount of data used. All right, so let's try it. For 1 gig, okay, 15 times 1 is 15. That works. What about 2 gigs? $30. That matches. Okay, so we want to use multiplication because that's what matches the values of our table. All right, so based off of 1 and 2, we have some information here that is definitely going to help us out with 3 and 4. I'm going to leave those to you. I will highlight some key pieces of information, so a little bit of annotation. So 20 gigs of data. The important piece is that we are given the data here. So you want to use the expression from up top and you want to plug in for the data. Next, Seth thinks 8 gigs of data will cost $120. Explain his error. So I'm telling you right now that this is incorrect. It does not cost $120. So first, if we're thinking about steps, let's first solve for the cost of 8 gigs. And then second, after you solve for the cost, explain his mistake. So 3 and 4, we're going to want to submit those answers. Again, any questions, please let me know.